y equals to sine square cot inverse of square root of 1 minus x by 1 plus x. What is the derivative of this? Now whenever we have inverse function, so whatever we have in brackets after the inverse function, we have to get it in terms of that function, cot inverse in terms of cot or tan, so that we can nullify the inverse function with the function. Now what value I have to take for x so that I can get square root of 1 minus x by 1 plus x in terms of tan and cot. Let's go ahead and see what happens if I take x equals to cos 2 theta. Then 1 minus cos 2 theta is 2 sin square theta. 1 plus cos 2 theta is 2 cos square theta. So square root of 1 minus x by 1 plus x equals to square root of 2 sin square theta by 2 cos square theta, which is equals to tan theta. But tan theta can be written as cot of pi by 2 minus theta. So cot inverse and cot will cancel. Our problem will become much easier. Once we understand this, let's go ahead now to our function given y equals to sine square. Let's write down the function and start with the substitution. X equals to cos 2 theta, because we checked what happens when x is cos 2 theta, and we are able to get square root of 1 minus x by 1 plus x transformed into cot function. So first let us see what is square if x equals to cos 2 theta. So let's write down let x equals to cos 2 theta. Now square root of 1 minus x divided by square root of 1 plus x equals to tan theta. We checked that already, so we can go ahead and write down that's equals to tan theta, which is equals to cot of pi by 2 minus theta. So now the function will become y equals to sine square cot inverse of cot of pi by 2 minus theta. Cot inverse and cot will nullify each other, so we are left out with y equals to sine square of pi by 2 minus theta. But what is sine pi by 2 minus theta? By trigonometric ratios of complementary angles, we know that sine of pi by 2 minus theta is cos theta. So sine square of pi by 2 minus theta is equals to cos square theta. But what is cos square theta with respect to our x? That we have written already. 1 plus cos 2 theta is 2 cos square theta. So cos square theta is 1 plus cos 2 theta by 2. So y equals to 1 plus cos 2 theta by 2. But cos 2 theta is nothing but x. So y equals to 1 plus x by 2. So whatever the problem given to us, which is complicated sine square of cot inverse of square root of 1 minus x by 1 plus x, is simply nothing but y equals to 1 plus x by 2. That much simple. So once we know y equals to 1 plus x by 2, we can just go ahead with the derivative differentiating with respect to x. We get dy by dx equals to 1 by 2 plus x by 2. 1 by 2 derivative is 0 and x by 2 derivative is 1 by 2. So dy by dx equals to 1 by 2. So whenever we have a derivative, we are finding out for the inverse functions, we always have to make sure that we nullify that inverse function with whatever the argument we are taking for the cot inverse. That will transform to the cot inverse will transform to tan or cot, cos inverse will transform to cos or sine, like that, so that the problem becomes simple and we can easily solve it.